Hi students, today we will discuss about the relationship between the current and the drift velocity. In our earlier class, we have already discussed about the drift velocity. So what do you understand by drift velocity? The average velocity with which the electrons get drifted from the negative terminal of the battery end of the conductor to the positive terminal of the battery of the conductor. So the drift velocity was earlier already we have discussed. That thing is here Vd is equal to, we have already derived this expression, this is minus E by m into tau, right? Or in terms of potential, we already got this E for electric field intensity, this will be potential gradient, that is L into tau. So this already we have derived in our earlier derivations. So now what is the relationship between current and drift velocity? So you know what is current? Current is the rate of flow of charge. So suppose we are considering a conductor of length L and the cross sectional area of this conductor is suppose A. So this is connected with the battery like this. So this is your positive terminal, this is your negative terminal. So the electrons which are moving inside the conductor, they will align themselves from the negative direction to positive direction. Why? The positive that will attract the negatively charged electrons towards this side and negative terminal that will repel. So we get the movement of the electrons from this side to this side. So this direction is the direction of electronic current. So what will be the direction of conventional current? Conventional current, you know, that is the direction opposite to the direction of flow of electron. So the current direction will be in this, right? So now what we have to find out? We have to find out how many electrons or the charge carriers are inside the conductor. So the length of this conductor is your L, the cross sectional area is your A. Then if the electrons are moving with a velocity of Vd, so the time taken by the electrons from this end to reach this end, this will be equal to, you know what is time? Time is equal to your distance by speed. Distance by speed. So what is distance? Distance is your L, the length of the conductor. And what will be the speed? The speed with which the electrons are moving. So that is your drift velocity, right? So the electron will take time t seconds to move from this end to this end with a velocity of Vd covering a distance of L, right? So now we have to find out what are the number of electrons present inside the conductor. So now for this what we will assume, let the electron concentration is small n. You know what is electron concentration? The number of electrons per unit volume. So small n is equal to your number of electrons per volume. So in this case, suppose number of electrons is your total number, that is capital N, and volume, what will be the volume of this conductor? This will be cross sectional area into length. So you know A is equal to cross sectional area, right? So this will be A into L. So if we want to find out the total number of electrons available inside the conductor due to who is the current is flowing in the external circuit, so that will be your capital N. So this will be equal to NaL, right? So this we get the total number of charge carriers which are available inside a conductor for the conduction of current. I think this is clear. Now You know what is current? What is current? Current is total charge flowing per unit time. So here we can get the current I will be equal to the total charge upon time. So what will be total charge? You know the property of charge, that is quantization. So if n number of total electrons are available, then the total charge will be n into E. So here the total charge will be n into E upon time. So by putting all these values, we will get this will be NaLe upon T. So for T, you know we can put this value. So this will be L upon Vd. So here this will be NaLe upon this is L. Vd will be taken to the numerator. So this LL cancels out. So we will be getting NaVdE, right? So we get the derivation for the current. So in a conductor, the amount of current which is flowing, that is related with the drift velocity and the availability of the electrons and the cross-sectional area of the conductor. So the final formula for this will be equal to your I is equal to NaVdE, right? So similar